Well, this is a really bad picture, isn't it? Good thing we don't have to even do this question. So skip it. Let's go on to the next one. Sorry, this is a bad picture too. I guess my camera wasn't focusing. Okay, anyway, the answer is choice B, as in boy. Okay, so they want to know all the x coordinates of the points of inflection. So I'm going to take the first and I'm going to take the second derivative. Okay, so first derivative is going to be 5x to the sixth plus 24 x to the fifth plus 30x to the fourth, and then plus 1. All right, let's do the second derivative. So second derivative is equal to 30 x to the fifth plus 120 x to the fourth plus 120 x cubed. Okay, so points of inflection, let's set them equal to 0. I'm going to take out a 30 and an x cubed, and that's going to leave me with x squared plus 4x plus 4. Let's set that equal to 0. So that's going to be 30 x cubed, x plus 2, x plus 2. So then if I t-chart that, oh boy, that's x plus 2, by the way. That's x equals negative 2 and x equals 0. Now remember, we have points of inflection when our second derivative changes sign, and it doesn't matter whether it goes from positive to negative or negative to positive. So negative 2 and 0. And then if I were you, I would just plug in any values that you want. And I would always plug it into the most factored part of the second derivative. It just makes life a little bit easier, I think. Okay, so then when you do this and you plug in numbers, I get negative, negative, positive. So you should see that negative 2 can't be a point of inflection because there's no sign change here. So 0 is the only point of inflection. So then the answer is choice B. Okay, the answer for number 26 is choice D, as in dog. So if you got that, you can skip ahead. Now, I'm so sorry for the blurriness. It's going to happen for the next few questions. I don't know what happened with the camera part of my iPad. But anyway, all right, so they're talking about a normal line, equation of a normal line. So I automatically jump to y minus y1 equals m times x minus x1. All right, well, they did give me the point, the x value of 3. So that's going to be x minus 3, right? Okay, so then I need to find the slope, which would be m, and I need to find my y1. Well, I can find my y1 by plugging in my x equals 3 here back into the original function. Okay, so when you plug in x equals 3 into here, you're going to get 3 squared, which is 9, 9 minus 1, which is 8. And the cube root of that, which will be 2. So then over here, I can write y minus 2 equals. Now I still don't know the slope. And the slope, obviously, then I'm going to have to take the derivative. So I'm going to leave some room and I'll write the derivative down over here. So y prime is going to equal, now that x squared minus 1 is technically to the 1/3 power, so I'm going to do power rule, which is going to drop that power in front, x squared minus 1, and that's going to be to the negative 2/3 power, and then times the derivative of the inside, which is 2x. Okay, so y prime equals, and let's see, what am I going to have here? I'm going to have 2x, and then I'm going to put a 3 down here, and then I have the cube root of x squared minus 1, that quantity squared. Okay, and then I'm going to be plugging in what, x equals 3, so that's going to be 2 times 3, and then we've got 3 times the cube root of 3 squared minus 1, and then we're going to square that quantity. Bloop. Okay, so when I work all of this out, that So then that's going to be 1/2. Now let's just be careful because that's the equation, I'm sorry, that's the slope of the line, or I should say the slope evaluated at 3. However, they want the normal line, and remember the normal line slope is going to be the negative reciprocal of that. So let's just be careful when we go up here, then I'm not putting in 1/2, then I'm putting in negative 2x minus 3. All right, so let's just do a little distributing. So I've got y minus 2 equals negative 2x. That's going to be plus 6. I'm going to move that 2x over to the left, so that's going to make that positive 2x. And I'm going to move that negative 2 over to the right, which is going to make that 8. And then if you look at that, that is choice D. Okay, the answer to number 27 is C. Now, they say that I'm looking at the second line, that the particle's velocity, right here, velocity, and the acceleration are both positive. So that means if the velocity is positive, that means the function is increasing. Okay, so when the velocity is positive, and I'm going to write that down here, velocity is positive, that means f is increasing. And then when the acceleration is positive, that means the function is concave up. Okay, so you're looking for a picture that's increasing concave up, so that's choice C. All right, 28 is another one that you can skip. We don't do that anymore, so go on to 29. Okay, now when we start getting to 29 and on, remember that these are calculator questions. The answer for 29 is C. And simply put, this is the definition of a derivative. So they're telling you that the derivative is equal to 0. And the only choice that says that is choice C. The answer to number 30 is choice A. And if you look at all the choices, they all center around the x value of 2. So if I look at the picture, I've got f prime. And so I know f prime of 2 is equal to 0. So that one's easy. So then basically I want to find something out about f double prime of 2, and I want to find something out about f of 2. All right, so let's start with f of 2. So if this is f prime, then isn't f the integral? And an integral is the area under the curve. So f of 2 would be the area under the curve from 0 to 2. And look at the area under the curve. Do you see it's negative because it's underneath the x-axis? So then I know, I don't know what the number is, but I know it's going to be, a negative number. Okay. All right, so then let's look at f prime of 2. I mean f double prime of 2. Well, I'm going to do a sign chart. So if I have a picture of the derivative and I want the second derivative sign chart, I look for increasing, decreasing. And well, that thing is always going up. So that means f double prime of 2 has to be some positive number. So then if we're trying to put things in order, the only one that makes sense from least to greatest would be choice A. 31, the answer is choice A. So what I did was I looked at this chart and I noticed, this is the chart for f prime, and I noticed that prior to x equals 0, my values are negative, but after x equals 0, my values are positive. So if I was doing a sign chart for f prime, I would have negative here and I would have positive here. So then I see that x equals 0 is a minimum. And if you look at your answer choices, choice A says that f of x has a relative minimum at x equals 0. So number 32, the answer is B, which would be 7 million. So this is a wordy question. But if you look at the second sentence, it says, in order to sustain a steady catch each year, a limit of blah, 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 million fish are to be caught. So this represents the millions of fish that need to be caught, or that are caught. How about that? Okay, and then if you read the last sentence, which is the question that it's asking, it says, what is the number of fish which should be left to reproduce each year? Here we go. So that the maximum catch may be sustained from year to year. And because this is talking about a maximum catch, and up here we're talking about fish caught, we are going to find the maximum of this. Okay, so I'm going to repeat that again. This little expression here represents fish that are caught. Okay, and the question is referring to the maximum fish that are caught. So if this represents fish that are caught, and we want to find the maximum, then basically what we are going to do is we are going to take this. Now remember, this is a calculator question. I can simply put this in my calculator and find the maximum. It's that simple. What's hard is reading and interpreting the question, and I understand that that's really not the easiest thing to do on this question. So if I were you and you're Y1, take your calculator and you put in this. Okay. Now I'm just going to show you what I put in for my window. So when I went to window, my X values, I went from 0 to 20. And my Y values, I went from 0 to 100. You should see a good picture. And then from there, just do second calc max and you'll get choice B, 7 million. The answer for 33 is D, as in dog. All right, so let's just look at these. These can be a little tricky. So I'm going to look at Roman numeral 1. What this is saying is the derivative is less than 0. In other words, the derivative is negative. Now, you don't have a graph of the derivative, you have a graph of the function. So then in this case, derivative really means the slope is negative when x is greater than or equal to 0. I'm going to repeat that again. This is saying the slope is negative when x is greater than or equal to 0. So let's go up to the picture. X is greater than or equal to 0. So starting here and working our way to the right, is this slope negative? Yes, it is. Okay, it's decreasing. So therefore, Roman numeral 1 is true. So I'm just going to put a little t there for true. All right, now let's look at Roman numeral 2. So this one's a little bit different. This one's saying the limit as x goes to infinity. So in other words, look at the picture. And as we go toward infinity, in other words, moving to the right, is the slope approaching 0? That's what this is saying. As we go to the right, is the slope, aka derivative, approaching 0? And let's look. As we move to the right, do you see that the slope is bottoming out? It's becoming shallow. So it is becoming more horizontal. So then Roman numeral 2 would also be true. So let's look at Roman numeral 3. And it's similar to Roman numeral 2 in that the limit as x approaches negative infinity. So in this case, we're working and going toward the left. Are the slopes approaching 3? Okay, now remember, let's go back to Roman numeral 2. As we were going toward infinity, the slope was getting more shallow and the slope was becoming more horizontal, which means going towards 0, right? Over here, as we go toward negative infinity, so we're going like this, right? Look at what's happening to this slope. Not what number is it approaching. It wants to know what is the slope becoming. And this slope right here is becoming more horizontal. It's approaching 0, not 3. They tricked you. It's going toward the number 3, but the actual, I should say the f of x is going toward 3, but the slope itself is bottoming out, okay, and getting closer to a value of 0. So this would be false, and that's why the answer is choice D. Okay, so the answer for number 34 is B as in boy. So they give you this integral here up at the top of the page, right here. And then they say which of the following could be the graph of this. Well, I'm not really sure about this right now. So what I'm going to do is I basically want to see this somewhere down here, and I don't right now. So if I look at the original equation that they gave me, I know this is x, right, and this is a. Okay, so let's think about this for a second. Do you remember when we were doing fundamental theorem of calculus? If I took the derivative of an integral, do you remember these guys canceled out? And since the lower bound here is a constant and the upper bound is a variable, this variable just drops right into the t spot. Do you remember that? Okay, so just go with me for a second on this. Oops, let me just go back to my black pen. So then what that would give me then is if I take the derivative, that's going to give me g prime on the left, and on the right, I'm just going to get f of x. Does that make sense? Okay. All right, now I'm trying to make it look more like this. Watch. So now let's say I take the second derivative. Well, if I take the second derivative, or let me back up, I'm going for the second derivative, but to go from here to here, I'm actually taking a derivative, right? So I'm going to take a derivative of this, which would really be f prime, but isn't it also the same as that? This is really saying f prime of x. It's just writing it in kind of a funky way. So this really is d dx of f of x, aka f prime. But I'm just putting it in the form that they gave you in the question. So then if you look at this right here, what they're really asking you is saying which of the following could be the graph of g double prime. Okay, because this is g double prime. And you have a graph of g. So let's think about sign charts here for a second. So if you have a graph of g and you want a g double prime sign chart, which we don't really do this very often, but in this question we do, we look for concavity, right? Okay, so we're looking for concave up and down. So I see, and this may not come out beautifully, so I apologize. Oh, that's not too bad. Do you see I have a change in concavity right there? And so if I look at that, I can also see I have a change in concavity right about there as well. Okay, you can call those whatever letters you want, or you don't have to call them anything if you don't want to. But that's where I have changes in concavity on my sign chart. So I'm starting out here at A. I'm going to be ending here at B. And then I'm concave down till I hit that first point right here. Okay. And that's going to then make it, oh, I'm sorry, I messed that up. Pretend that's not there. I'm concave down. Then I go to concave up, right? So let me just kind of go back. Here the picture's concave down. Then here I'm concave up till I get to the second point here. And then I'm concave down again. Okay? So then that's going to be negative, positive, negative. So we're looking for a graph of the second derivative. And basically, if we have a sign chart for the second derivative, and we want a graph for the second derivative, we're just looking at below, above, below. And the one that does that would be choice B. The answer to number 35 is choice C. So this is the graph of the position, right? And it says here, which of the points marked is closest to the point where the acceleration first becomes negative? Okay, so acceleration being negative would be where we first turn to concave down, right? So I'm looking at the point where the graph first starts to become concave down. Well, if I start here, I'm concave up, concave up, concave up, and right here at C is where we start going concave down. So your answer is choice C. All right, the answer for number 36 is E. Right, oops, thought I had my pen going. So the answer is choice E. If you look at this one, they give you the derivative, but the important thing that they're telling you right here is it says at what value of the function is there an absolute minimum? Well, if a function has a minimum, that would be where the derivative is equal to 0. I'm going to repeat that again. So if the function has a minimum, it's where the derivative is equal to 0. This is a calculator question. So I wouldn't bother taking that derivative in your head, no offense. I would go straight to your calculator and in your y1, put your f prime equation in there. Okay, so if you have to turn me off for a second, pause me and put that in. All right, so then what I did was I used x values from 0 to 5 and my y values were from -10 to 10 so that I could get a nice picture. So then when I do that, I'm just going to, and we do have endpoints here, 0 to 5, and this is f prime. So you're just going to do second calc 0, right? Let me just double check. Yep, second calc 0, which is number 2. So you can figure out where the derivative is equal to 0. That would be, where the graph hits the x-axis. So I had 2 places where it hit the x-axis. So I had it at 0.618. And I also had it at 1.623. Please make sure you're doing this in your calculator on your own. Because if you don't know how to use your calculator and get these values, you're going to be out of luck the day of the AP. All right, now if you look at your graph, you'll see between 0 and 0.618, the graph is below the x-axis. And between 0.618 and 1.623, it's above the x-axis, and then it drops below again. So just remember what we know about that. So then what that does is we have a minimum here. Okay, this is a maximum. And remember our endpoints alternate. So this is a minimum and 0 is a maximum. And the question's asking for an absolute, so we have to be very careful, absolute minimum. So let's talk about this for a second. An absolute minimum, well, we have 2 minimums, so the answer is either 0.618 or it's 5. Well, obviously we know the answer is 5, but the reason being is if you look at the picture, the area that's under the curve at x equals 5 is going to be larger than the area under the curve at 0.618. Look at your graph, and you'll see that this has a larger amount of area underneath than this one does. And they want absolute, which means the most minimum, and that's why we're going with x equals 5. So the answer to number 37 is D, as in dog, 2.340. This we did a long time ago, but we did it. When we see something like this, and then we have a chart of f, this is mean value theorem, okay? So we're going to do f prime of 4 equals, so remember that's f of b minus f of a over b minus a. And again, make sure you're taking notes on all of this stuff if you're getting it wrong. So we're going to be doing f of 4.002 because I'm going higher, 1 higher than 4. Or you could go 2 higher than 4. I think that's apparently what I did do. It does not matter. Minus f of 3.998. Okay, and I'm going to repeat what I just said. Let me just show you on the chart. Here's 4 right here. You could go 1 higher and use these 2 values and these 2 values. It doesn't matter. I just went to the farthest away and the farthest away, okay? I would go the same amount in either direction, but it doesn't matter. All right, so then we're over 4.002. My decimal didn't come out there. Minus 3.998. Okay, and we know what f.4002 is. Look at it in the chart. And then just do the calculations in your calculator. So the answer is choice D. Alrighty, so this actually is a really easy question, but I can almost guarantee you, no offense, that you forgot this little tiny rule. or tiny fact, I should say. And if you know that fact, this is a piece of cake. The answer is B, as in boy. So here's the thing that you probably don't remember. No offense. But we did it probably back in, I'm thinking, October. This sine of x over x, it was called the sandwich theorem. And I'm actually going to write it over here. And what it was the limit as x approaches 0, which this is doing because look at your domain, of the sine of x over x, that equals 1. Okay? And I know that that's kind of hard to remember because we haven't done it in a really long time. So, but that knowing that, and it is telling you that the function f of x is continuous, so we know that these two should be equal to each other, right? Well, so we know the sine of x over x when we're doing the limit as x approaches 0 is 1. So then what we can basically say is 1 is equal to k, and there is no solving. K is 1. That's choice B. Okay, 39, the answer is D. Now, if I were you, I mean, this isn't, I don't think, too terrible. You're going to graph, and it doesn't matter which one you put in Y1 and which one you put in Y2, but I would put one of them into your Y1. I will put the other one into your Y2, because this is a calculator question. Okay, and then it says that they intersect 4 times. So just, by the way, I used 0 to 5 for my x minimax, my window, and I used -2 to 2. This will give you a good picture. Okay, and then really what you're doing is you're looking for the largest space in between those two graphs because that's going to give you the largest number. Okay, because they want the definite integral to represent the largest number. So in other words, between which two letters, you know, is it between A and B? Is it between B and C? Are you going to have the greatest area? And that would be choice D, between C and D. Answer for 40 is C. So it tells you that the function has 1, 0, and it wants the derivative at that point. Okay, so I would start by figuring out where the function, the tangent of 3 to the x, equals 0. Well, you have a calculator. So I put this in my y1 and do second calc 0 and see where it hits the x-axis. So when you do that, you're going to get x equals 1.04198. Okay, so now you want to know what the derivative is at that point. So remember that you can do this in your calculator. So then what I did was I have the tan of 3 to the x, this right here, is already in my y1. So then I went to my home screen, okay, and I did math 8 of my y1, vars, y vars, enter, enter. And then I just typed in the value. And you'll see that I get 3.4 blah, 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 which is choice C. The answer to 41 is D. Okay, so if we look at this, they want a Riemann sum, 3 intervals with 2. So I would say there's one interval, here's the next, and here's the last. However, they want you using the midpoint of each of those 3 intervals. So I'm going to draw a little arrow. There's one midpoint, there's the other, and there's the last, okay, because that's the middle of each grouping. So we know that the width of each of those, if you look here, is from 0 to 2 is a distance of 2, from 2 to 4 is a distance of 2, and from 4 to 6 is a distance of 2. So I know the width of each of my rectangles is going to be 2. And then I use the height of the midpoint, which is for the first one, 0.25. The second one is going to be 0.68. And the third one is going to be 0.95. And then you just work that out, and that's going to be 3.76. which is choice D. The answer is choice C for 42. So when we do this one, remember we have fundamental theorem of calculus here. We're taking the derivative of an integral, so those cancel each other out. However, look at our bottom bound. Our bottom bound is not a constant. So remember when that happens, not too bad, we just have to take each one of these one at a time and plug them in for t. Okay, so for the top bound first, I'm going to do the sign of, now I see a t, so I'm going to write x cubed, but that quantity is going to be squared. Here's the only extra thing that we have to remember. When we do that, remember that we have to take the derivative of that top bound and write it in front. So I'm going to have a 3x squared in front minus, and I'm going to do the same thing, this time plugging in my bottom bound into here. Okay, so that's going to give me the sign of, now I see a t, so I'm going to put my x in there, and I'm going to square that quantity. And just like I did with my top bound, I took the derivative of x cubed, and I put it here. I have to take the derivative of x, and I have to put it there. Now, in this case, it's just an x, so really that's just a 1, and we don't really need to write it, but in another case, it may not be. So there you go. Answer choice C. 43, the answer is choice D. Now, they're giving you this, and they're telling you that it's a rate, and then they say the tank is originally empty. So remember, originally empty would be at time 0, right? I don't know why I just wrote a V. Let me just erase that. There we go. So we know that that's at time 0, right? So let me just write that. How many gallons of water are there? So if you're going from a rate here to an amount, that's an integral. And we're going to integrate from 0 to 4. All right, so let me just set that up for you. So we're going to have the integral from 0 to 4 of 300. Well, I guess we could just write this radical t, right? This is a calculator question. We don't need to do this by hand. I was getting ready to. Oh, let me not forget to write dt. And then just plug it in your calculator. And your answer is going to be choice D. 44, answer is choice D. Okay, so with this one, I would just get a graph in my calculator. So I've got y equals x that comes out like that, and y equals 2 sine x will look something like that, let's just say. Okay, so I know if I do second calc intersect that my x value there will be 1.8954. 954. And what do they want? They want the volume. So we're taking that piece right there and we're revolving it around the x-axis. Okay, so volume equals pi times the integral from 0 to 1.8954 of the, now, let me just stop a second here. Hopefully you'll see that we have 2 radii, right? So here's my large radius and there's my small radius. Okay, so we're going to do the big radius squared. So my big radius would be 2 sine x, that quantity squared, minus the little radius, which is x squared dx, and then just throw that in the calculator and you will get choice D. Alrighty, 45, the answer is choice C. So I just started, look, I looked at this thing and I was like, huh? But that's just basically derivative. N could be 1, which would mean it's the first derivative. N could be 2, which means it's the second derivative. N could be 3, which means it's the third derivative. So what I started by doing was I just did a couple of derivatives. I didn't know what else to do. So I'm going to start with that. And you'll start to see a pattern. So if I do the first derivative, I'm going to do product rule, right? So I have the first times the derivative of the second. Remember, e to the u is just e to the u, plus the second times the derivative of the first, which is just 1. Now I notice there's a reason why I'm doing this, so just hold on a second. I notice that both of these terms here, this one and this one, they both have a factor of e. So I'm going to take that out, and there's a reason why I'm doing that. So if I take that out, I get x plus 1. Okay, let me go on to my second derivative. Now I'm going to take my second derivative, and I'm going to take the second derivative of this because it's easier. All right, so I'm going to do product rule again. So it's the first times the derivative of the first, which is really just 1, right? Plus the second times the derivative of the first, which is e to the x. All right, let me do the same thing I did on the last one. So if I take out e to the x, do you see that I have 1 plus x plus 1? Right? Let me simplify that. So that's e to the x times x plus 2. So what I want you to notice is, let me box this off, and let me box this off, and compare what happens from here to there. So then what you could probably most likely say then is the third derivative, without even doing it, is going to be e to the x and then x plus 3, and so on and so on. So now look at your choices, and you should see that it's choice C.